Hello everyone. So today we'll do an example of how to do a two-factor DOE using Excel. Similar to what we have done in class, we have four experimental runs 1 to 4 here highlighted, and we also had two variables, right? Variable A and variable B. You can think them as your wingspan and wing chord. It could be anything. And then as a response, we also measured some values, right? So we call this as a whole as the original DOE matrix. And based on this original DOE matrix, we are now forming our design matrix, right? And we have to make sure our design matrix is actually has the same number of columns as the same number of rows. So basically, to do that, we first set our identity or the first column, which is the all 111s, which kind of is related to our alpha 0. Then we basically copy paste our A and B factors, right? And any other interactions that we had. In this case, we had A times B. But if you have more factors, you have A times C, A squared, B squared, and so on. It will depend on how many experiments that you actually also run and how many variables that you had. Okay, once we have our sort of square matrix, right, design matrix, then we go ahead and find the inverse matrix. And to use the inverse matrix, you're going to use this matrix inverse function. Okay, so I'm going to run through this with you, and then it should be pretty easy to follow. So basically, since we have 1, 2, 3, 4, right, and 4 by 4 matrix, so you're going to select a 4 by 4, 1, 2, 3, 4, 1, 2, 3, 4, 4 by 4 area. And without deselecting it, you're going to start writing equal to, right, M inverse, right? And it just now tells us that M inverse returns the inverse of a matrix for the matrix stored in array, right? So we're going to have to give it an array, right? So we're going to open our parentheses, and then we're going to sort of like select our design matrix, right? Close the parentheses, and then the important thing here is that we're going to have to press Control Shift and Enter. Okay. Um, I think I did one extra parenthesis. It's asking me to fix it. I say okay, and as you can see, this new inverse matrix we have here is exact same in the inverse matrix here. So this is exactly how we do it. And then the second part is now we are trying to get the constants for our model, right? To do that, we have to multiply the inverse matrix, right, with the original response column or array, right? So to do that, we know that our response is going to be have four different constants, right? We are going to select our four different constants, 1, 2, 3, 4. And then we're going to again start writing matrix multiply, right? So that's the new function. We're going to write matrix um, multiply, open parentheses, right? This function expects two arrays that is going to kind of multiply together, right? First one, we are selecting our inverse matrix. And then the array 2 is going to be after comma, right? So we're going to put comma here, and then we select our response matrix. Close the parentheses, and again, Control Shift Enter, right? Control Shift Enter, and as you can see, this array is exactly the same as we got in here. So this is how you get your constants for your experiment, right? In this case, I'm just going to delete these two. We don't need them anymore. Okay, so now next thing is to check if the model is accurate, right? So let's check for our run number 2. So I go to my original DOE matrix and go for run number 2, right? And I can see our design matrix, right? It's 1, 2, 5, 10. And now I go and make my kind of polynomial, right? It's going to be alpha 1 times I, alpha 0 times I, alpha 1 times A, alpha 2 times B, and alpha 3 times AB, right? Press enter. We found 17, and our run was actually 17. So basically, this model can predict or kind of calculate back our kind of experimental data based on our design matrix. Okay, Now we know that our model is correct. What we want to do is to figure out what is the kind of the maximum, right? So we are trying to find an A and B values, right, that will maximize the response, right? So basically, to do that, you can do two ways. One way is to use a solver, right? And I will show you exactly how to do that. But you also would want to get some sort of visual confirmation, right? To get the visual confirmation, what I know, what I will do is that I will set A, right? That's our first variable, and B is the other variable, and then we'll call the other one as the response, right? And I know if I look at my original matrix or to my system, I know that A is varying between 1 and 2, and B is varying between 5 and 8, right? So what I will do is that I will want to get some sort of a continuous incremental values of A from 1 to 2, right? So I'll say 1, 1.05, and then I can select these two and extend it in matrix until I reach number 2, right? Okay, that's 2 right there. And for B, I know that I start from 5, and let's say I increment in 5.2s. I just select these values so that I actually have same value. See, I hit here 9, but I know that I go to 8, so I will change this to 0.15. You don't have to do this. It's just kind of give you a visual confirmation of what your response looks like. And if I do 1.15, now I have 8. For our response, what we are going to have now is you're going to say this equals to, right, alpha 0, right, plus it's going to be alpha 1 times A, right, plus alpha 2 times B plus alpha 3 times A times B, right? So that's our response. I'm just going to propagate this. Oops. What happened was that these responses also kind of propagate together. So I'm just going to fix them. You can do this by pressing F4. Basically F4 here, F4 here, or you can put dollar signs in between, so that says that it's fixed in X and Y directions as you propagate. Okay, there you go. Now try one more time. There you go. So to do this, I'm selecting all three variables that I have, right? And I want to insert a graph that will show me how these values change. Then I go to basically a 3D surface, right? Look at my 3D surface, and if you want to do a little better job at looking at what these actually are, you can go to Series 1. Series 1 is going to be A, right? I can name this A. I can name this as B, and I will name this as the response. There you go. Okay, so now what we know, what we see here is that here's the response, that's the z-axis, right? And here's our B and here's our A, and as I can see is that it maximizes at 30 when A is 2 and B is 8, right? So basically it's kind of a linearly increasing function. Here's kind of my maximum. Okay, so this is how you look at graphically. Sometimes it's not as easy to find this in graphical format. So we have another way of doing it. That will be here using a solver. Okay, so how we do this? So solver basically works in two ways. One, it will help us to find a particular response and that tells us what are the A and B values for that particular response, right? Or we want to say the maximum or minimum of that response, and then it will tell us what are the factor A's and factor B's that will do this, okay? So to do this, let's say, let me delete these for now, right? Let me delete these for now. and say, in this point, we are just basically rewriting our equation, right, that we have set. So basically, what we have is alpha 0, right, plus alpha 1 times A, alpha 2 times B, plus alpha 3 times A times B, right? And in this case, I set A and B as here, a factor A and factor B. So these are, for now, empty, right? This is what the solver is going to give us. And then when you say, um, you have to go to your solver, okay? The solver is in data, and there's a solver button, okay? So if you don't have this solver, what you are going to do is now you're going to go to File, and you're going to go to Options, and from Add-ins, right, you are going to have to say Analysis Toolpack, right? This is right here. Every Excel should have it. And you're going to say press Go. And from this button, you're going to select Analysis Toolpack, VBA, and Solver Add-in, right? You're going to press OK, and now your solver should be right here, okay? So basically, we are going to press the solver, and then the solver is going to ask us a couple questions, okay? So set our objective. In objective is the function that we are trying to maximize, right? We are going to put this as our target or the response, however we're going to name it. And we want to maximize this function, our objective, using two variables, right? I'm going to go press this button and then select the two variables as A and B, right? And we are trying to find the maximum, right? And I am also setting a constraints, right? I know that the our factor A, right? Basically here, our factor A. Okay, let's delete these first, so you'll have an idea of what we do. Delete, 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 delete. Okay, there you go. So we have no factors now, or constraints. So first constraint is now I know if I go back, my A is changing between 1 and 2, right? So I can go here, select this factor A, and we're going to say it's smaller or equal to, right, 2, right? That's our first. I'm going to say add. And I'm again going to select the factor A, and it's going to be smaller or bigger or equal to 1, right? So that's our constraints for factor A. Then I'm going to add one more, and I'm going to say for factor B, right, it is smaller or equal than 8, right? That's the maximum it goes. I'm going to add another one and say factor B is going to be bigger or equal to 5, right? I press OK, and these are all the constraints that I have on my system. I'm trying to find the maximum. I'm going to say solve, and it's going to give me a window saying that the solver found the solution, all constraints and optimal conditions satisfied, and you're going to press OK, and it's going to say number 2 and number 8 is the maximum. That will give you 30, and if you look at our graph, that's correct. If you get exactly the same thing that we did. Okay. The other use of solver is that if you want to go ahead and find a particular value, right, you can go to solver again. And instead of finding maximum, you're going to say find a value of, right, it's 16.9, right? So you're going to press 16.9, and you're going to say solve. It's going to say solver has found whatever it is, right? And it's going to tell you is that 1.151, right, and 7.755 is going to give you 16.9. So what happens is that now you have found your factor A and factor B that maximizes the response, right? So what you are going to do next, right? What happens next week is that, let's go to PowerPoint here, and say we had this square, right, that we always had. Let's stay everything in 2D, okay? And this new A and B value, right, that you have found is going to become your center measurement, okay? So that's going to be your, say, A max and B max, right? Let's make it a little bigger. So it's going to look, okay, so that's going to become your center, right? That you have found. And then in your case, you're going to have ABC, right? And we are going to set these values, right? So that this part that we have here, right, is going to be, let's try to be nice. Here is going to be 50% different, right? That's going to be 50% of A, right? And then that's going to be the 50% more of B, right? And then this will become your new measurement space, right? So, and then next week you are going to use this new kind of parameter space and then try to find a new center point, and then that will become the optimized flight. Okay, so if you have any questions, please let me know or send me an email, but this should be pretty straightforward to figure out what is the optimized center point for your next flight.